Hello and welcome to the first Blender tutorial for Python. This will be a tutorial series of around about 10 parts or so. We'll go from the basics, assuming you know no Python or programming language at all, but we'll include references to C++, all the way down to classes, functions, object-oriented definitions. Now, first things first, don't be scared. Python is very easy to learn. In fact, I'd say it's easier than any language in terms of French or Spanish. It's quite quicker to master because its functions, variables make sense. They sound English. When you read them, you generally understand what they do. The most important thing you must learn is to always use the right techniques efficiently, but also to name them correctly so you can understand them later on. We'll cover both Python in the Blender game engine, most specifically. However, we will also cover generic Python in the real world. So let's begin. When you open Blender, you'll be presented with this main scene. Now, in order to do coding in the game engine, you must do two things. Firstly, select Blender Game from the drop-down, and then you must select the Game Logic view. Now, we will work off the default cube for now, adding an always sensor and a Python controller. If you don't know how to use the logic bricks, then you really must first look at Guillaume's tutorials on the Introduction to Blender series. So, create the always and the Python and connect the two by the node tag thing. And then create a new script in the text window, which is on the right, and select it in the drop down. I would name this something that sounds correct, that you can remember, such as functions.py. You don't have to have the .py extension, but it's useful for later on. Now I'm going to create a new text document and show you what we plan to do over the series. Today I'm going to cover data types. We'll try and keep these tutorials short so I can keep more specific data and get them out quite fast for you. So today we're going to be covering data types and how they work, and possibly variables and operators as well. So back to functions.py. The default cube is a game object, and I was having a discussion with someone on the Blender forums, and the Python controller technically bends the sensor controller actuator, or SCA concept, which is you must have a sensor activated to controller which activates the actuator logic brick, because in fact you don't need actuators for certain types of functions. Just a little bit of background information. First things first, we're going to work with generic Python. So with Python we have something called variables. Now variables and all other types of data are in fact forms of data types. Data types are merely ways of expressing certain types of data. For example, you'd express a graph as a series of data. You would express words as a string in terms of computing. You would display numbers as a 1 or a 2 or a 3. But you can have different types of numbers. For example, you can have floats which have a decimal place, or integers which have no decimal place, are whole numbers only. Then you have fractions, which are essentially just integers divided by another integer, or so on. And you also have lists, if you think shopping lists, and dictionaries, if you think a language dictionary. So let's look at the basic integers. An integer is a whole number, and it's very easy to do in Python, because in Python you don't have to define functions or variables. Sorry, you don't have to define variables before you use them. You simply set them as x equals 1 or x equals hello, etc. So let's create a new script. Let's make a mathematical operator. So first things first, we'll make a script that adds maybe 4 and 6. Now, how are we going to do that? Well, let's work off just numbers for now. So in order to show the results of our maths experiment, we're going to need to see what we've typed. But in the game engine, this window, if I press P, will not change. You can't see anything. Your mouse disappears and you're in the game engine mode. So in order to see what changes we have, we go to Help, Toggle System Console, if you're on 2.6 or 2.59 I believe, and drag your window to the left on Windows 7 or make it smaller. Now, here you have the console, and this will display any output you decide you want to show the console. To show the console data, you must use a print statement. So this is going to be the first bit of code you see. Print looks like this in Python 3. In Python 2 it looks like that, but we're going to work in Python 3 for now. Anything in these parentheses will display itself to the console. So let's work with integers. An integer is a number, integer, 1, whole number. So in this case, if I were to print 1, it would realise that this is an integer because it's a whole number and it hasn't got speech marks around it, or any other operators. Therefore, this is a integer. If I press P to start the game, it prints 1 to the console. That's all well and good. If I print a 1 plus 2, that uses a plus operator, addition, and that will, as you expect, result in 3. Other operators include subtract, divide, multiply, and you can use increments, but that's not for now. That's how the integer works. So, in order to display integers in scripts, you can do it as we've done, adding them in statements. However, it's easy to use variables because you might want to change them later on in the script. So the best way to do it is to create a variable with your two numbers and add them together. To create a variable, you simply type its name, followed by an equals, with or without a space, and then another space or not, and the result value. So let's create number 1. Number 1 underscore 1 equals 2. That is a variable. Number 1, the variable number 1 has been assigned the value 2 as an integer because it has no parentheses, nothing on it, just number 2. Number 2 on a new line equals 8. That will give number 2 the value, the variable of 8. Now, if we want to add these two numbers together, we can, in fact, print these in the console because it realizes these are now variables. So we can print number underscore 1 plus number underscore 2, and this will print the addition of these two variables, which will then find 2 and 8 because variables work in a reference. In other words, unless you explicitly set it to copy the equal thing in equals, it will refer to the number. This is useful later on when you have variables equaling other variables. So essentially, number 1 will actually be interpreted as 2, and number 2 will be interpreted as 8. So this should equals 10. Very easy. Now, we could actually make this simpler and cut that. Number answer equals number 1 plus number 2. These equal variables. Print number underscore answer, and indeed we have the same thing. These are integers. To show you a quick demonstration of floats, we shall do a float. So clear the print statement. Leaving this intact, we'll just print a new line and type float underscore 1 equals 2.6. Float underscore 2 equals 1.4. Then we can do float underscore answer equals float underscore 2 plus float underscore 1. You'll notice that we cannot, in fact, leave spaces between these variable names, because if we do, we'll have the word float, then 2, and then equals 1.4. That will cause sort of errors, and you won't have a clue what's going on because you've left a space. The reason I haven't used just the word float is because in Python we can check the types of variables by referring to their reference and their definition, and a definition of a float is called in Python as float. And the definition of an integer is called as int, int, and so on. So we don't use those data names as variable names because it gets very confusing later on, and it could cause problems in your scripts. So if we print float answer, we should result in 4.0. Very good. Floats in the properties window, as your game properties down here, only support 3 digits after the decimal place, if you excuse me 1 minute. So that's floats. Let's have a look at strings now. So clear your print statement and look at string. String 1 equals, now put quote marks because it's a string. Strings have quote marks, either speech marks or punctuation, whichever you prefer. Apostrophes, I call them. And I use apostrophes for this one. We'll say hello world, true to coding style. You'll see it says string equals, string 1 equals hello world. And if we print string 1, you'll see in the console, hello world. Very good. Now, the good thing about Python is you can use the addition operator, the plus sign, to add two strings together. So if we have string underscore 2 equals my name is Angus, and we print, string answer will be string underscore 1 plus string underscore 2. Gotta be careful you don't type things wrong. I'll make this a bit bigger for you. And string underscore print string underscore answer, and you'll see hello world, my name is Angus, but oh my gosh, there is no space there. That doesn't look right. That's because it's literally added one to the end of the other with no space. So you have two options. You could add a space at the end of hello world or at the start of string 2, and that would work. Or in the print string answer statement, you can put a comma. Now let me just double check that this works, because it doesn't necessarily always work efficiently. No, okay. So what we do is remove this statement here and print string underscore 1 comma string underscore 2. How does this work? When you put a comma between two items, it assumes they're part of a tuple or a list, I believe. Yes, it treats them as a tuple. Now, a tuple is another form of data type, and we'll cover it later on, so bear that in your head. All you need to know at the moment is that if you put commas in print statements, or in any position ever, as long as they're between variables, it will assume that they're two separate entities. But with the print statement, it will print them both with a space in between. So if we do so, hello world, my name is Angus, with a space. We could in fact add a comma there, putting in directly into here by adding the quote marks, commas either side to make sure it adds the spaces. If you don't, it will cause errors, because you have to add either an addition operator or the comma. Sorry about that. And then the comma key, and press P, hello world, comma, my name is Angus. Maybe we don't want that space there. In fact, I will remove this comma and add a plus, and you'll see it all works nicely. These are strings. Strings are used for text or for display in the game engine. They're used many other places as well, but this is the essential one. What else do we have? Well, we have done integers, we've done floats, we've done strings. Now we have a list, if I believe. I'll double check. Yes, we have a dict or a list. We'll look at lists first, that's more simple. So, do a new variable, list underscore 1 equals, but now you have to wait. A list is a bit like a shopping list. You have items in it, you can add them to the list or remove them from the list, and they go in sequential order. Now, the thing you have to understand about Python, and some other languages as well, is that it doesn't start at 1, in fact it starts at 0. So the first item in the list would actually be accessed by an index, and indexes are used to refer to items at certain positions in a list, like the first item is that index. However, indexes are in fact start at 0, so the first item would be at index 0. The second item at index 1. The last item would be at the number of total values in that list, minus 1. So, to create a list, use square parentheses, square brackets. This will be a new list object, as it detects the brackets and assumes that as a list. You can add values as soon as you create a list by adding in the value, then a comma, as we realised earlier. Adding commas will create a new item within a list or a variable. Don't worry if you don't understand it, it makes sense later on. Or we can add them during our script, but for now we'll predefine them as 1, 2, 3. If we then clear the print statement and print list underscore 1, you'll see it says 1, 2, 3. Now, let's say we want to add another one to the list. Very simple. List underscore 1 dot append. Now this dot append will add whatever's in these parentheses to list1 list object, and it'll add it to the end of the list. So let's add the number 4. This will add it to the list and then print the list, so we should see 1, 2, 3, 4, and we do. That's well and good. Let's suggest that you want to remove 2 items, in which case list underscore 1 dot remove 4. My bad. Now you could be really adventurous and try this, but you'll see it only takes 1 argument. This is because Python assumes these are new arguments. You could again try it with a list, but that would not work either, unless you add it to here. And you'll see if you add it with these brackets, the list doesn't work at all. In fact, I'll remove this and I'll show you. It'll add them in the brackets. So in fact, you can only add one item to a list at a time. So there's the append function, and here is the remove function, as we've just seen. Dot remove, and we'll make it remove 4 just to be nice. Okay, that is the answer to the list. That's all there are to lists. Let's say we wanted to find the second item in the list. Second underscore item equals list 1, because we know we're talking about list 1 here. And we want to find the second item, which is accessed at that number minus 1, because it starts at 0. So 2 minus 1 equals 1 at list 1. If we then print second item, you would expect to see 2. And you do. Very good. Now, I can't remember if you can assign to a list, so let me double check. That's correct, yes. If you assign an index of a list, if you assign the index of a list, it will set that position to that value. So, if we print list 1 after setting the second value at 3, you'll see now in the console the second value is 3. Very useful. This means that you can change values within a list. If you have a blank list and you don't do anything to it, and you then try and set a value that doesn't exist, it will throw up an error because you're trying to set the second value of the item of the list to 3, but it doesn't have 2 values. Again, if you try and set it an empty list to 0, the first item to 3, it doesn't have an item, so it can't work. So you must always have an item in the list, either by appending in or starting with it. I'll add this back in for you. There you go, and last but not least, that's lists for you. Now, we have now got dictionaries. Anyone who hasn't seen a dictionary before will be slightly confused. So here, think of it like this analogy. Whenever you look into a dictionary for your language, or for French, or Spanish, or Mandarin even, I don't know about Mandarin, you'll notice that you have to look up the word, and then you'll find the definition and how to use it. Now, that essentially means that you can find lots of information from one word. This is where dictionaries are useful. You can store lots of different types of information, more than one set of information, under one variable name. And it means you don't have to go setting lots of variables, because you can access them within a dictionary. So with that analogy in mind, I'll show you dictionaries. Let's make a new variable, dict_1 equals, this time we use curly parentheses, curly brackets. And again, you can have initial values or none at all. Let's first show you the initial values. You must have a key index, as it's called. No, sorry, key value. You access the item by its key and it will return the value, as you do in a dictionary. So, keys can be anything, but you have to learn later on that if you don't use variables, if you use objects themselves, which you'll then learn later on. Just remember the word objects. If you try and access them with objects, if those objects don't exist anymore, it doesn't work. Instances of objects don't work either. But for those of you who don't understand, just know that you can use anything as a key and anything as a value. Now, to make a key, you must put that key, let's say, shall we use hello, and we'll put a colon, and we'll give that to a definition of world, and add a comma. This comma means anything you add after this will be a new value in the dictionary, as we've seen before. Let's add another item called goodbye, in speech marks, a colon, and then world again. or if you add monde, because we're doing a bit French as well. You can leave a comma here or not. It's called a trailing comma if you do. It's sometimes good practice too, whatever you feel. Now, if we print dict1, you will see in the console, hello world, goodbye monde. And if we, let's say we clear this print statement, and we want to, let's say we want to add a new value to this dictionary. How do we do it? Simply type the name of the dictionary again. This time put a square brackets, as we've done here, because you can't append to a list, you can merely create a new item that doesn't exist already. So, to create a new item on the dict, you add the square brackets, as you've done here, and this will either, if it doesn't exist in the dictionary, it will add it. If it does, it will reset that value to what you set it as. So essentially it's this, but this with the append function, because if you don't have any values in this dictionary, it won't work. Whereas with this, it does. Let's say we want to set, let's set learning. That will set the key learning in the dictionary to a value by adding equals people. Don't know where I'm pulling these variables from, but there I am. So this will set the value of the key of learning in the dictionary accessing the value people. If we print dict1, we will now see hello world, goodbye monde, learning people. That's how you access. Now if you wanted to find a specific value from the list, if you wanted to remove a value, you then do the same as above, but instead of using remove, dict1 dot remove, you don't use dot pop or pop. You pop it from the list, the dictionary, curly parentheses, no, normal parentheses, my bad, tongue-tied, and you'll put the name of the key, which in this case we could remove hello. And we print dict1, and you'll see hello world is gone with its value. Let's try and set in, if you want to read a value from a dictionary, oops, dict_1, you can read it as the same way. You put the name of the key, which will put learning, or goodbye, and that will be the value. You could set this to a new variable, let's say value1 equals dict_1, goodbye. This will set the new variable, value1, to the value of the dictionary key accessed goodbye. And you look in the dictionary, the value of, the key of goodbye accesses the value of monde, so this will set value1 to monde. And if you print value1, you'll see monde. And that's pretty much there's all to it. Knowing that we have keys and values, we can move on. Probably the best step to take next in the tutorial is to look at using these data types, because these are all the ones you'll ever have. So let me just remove this example for you and get rid of the print statement. We can add one later. Now, most of the time you'll be using lists and dictionaries in Python. They get used incredibly often. So let's create a list of numbers. But we want to go through, we'll have a list of numbers, so list numbers equals the list 1, 2, oh dear, sometimes when you type numbers it accesses the ones in the position line number. Let's say have 1, 3, 5, 7, 9, and new numbers equals a blank list. Now what we're going to do is we're going to go through each item in this list, we're going to add 2, and then add that final value as a new item in new numbers. So for number 1, you'll have 1 plus 2 will go to 3, we'll add 3 to new numbers, 3 plus 2 equals 5, we'll add 5 to new numbers, and so on. How do you do this? Well, in Python we have something called loops, and they're used by for statements. Now for statements basically iterate, which is the term you should already know. They iterate through a list, and each item they come across, they will set it as a value, and then you can use that value. So a for statement is very simply the for keyword, followed by the variable you want to assign the item to. So let's say number in, and then after in, the keyword in, you must define which list you're accessing, or dictionary, or many data objects in fact, if anything. List numbers and add a colon because it's a statement which carries on. So this will, for each number in list numbers, it will make a variable called number and set it to this value. So we want to find out this value plus 2. So new value equals number plus 2 using the operator and the keyword. So for number 1, new value will be set as 1 plus 2, which will give it 3. Then we want to add it to new numbers. So new numbers dot append the append function new underscore value. And if we then go, you'll notice this is all indented. The only way to tell Python you've finished this comprehension, this for statement, is to get rid of the indent by making a new line and going back to the left margin. And then we can do print new underscore numbers. And this will run however many times, this bit of code here, will run how many times there are numbers in a list. And then it will print the value. So if I press P, you'll see 3, 5, 7, 9, 11, which is the correct way of doing it. So here you'll notice we've read items from a list and then added new ones to another list, which is a very good skill to have. Now, what else could we do? Well, we could be very adventurous and look into if statements. But first, we're going to look at how you do the same for dictionaries. Dictionaries are the same thing, but you have to remember, dictionaries, I'm just going to check my Skype. Dictionaries have keys and values. So, by default, if you try and use a for statement with a dictionary, it will look through the keys. However, if you want to get the key and the value at the same time, there are multiple ways of doing this. So let's create a new for statement. We'll create a new dictionary. No, dict underscore numbers equals curly brackets. We'll have 1 as a keyword and the value of 1, 2 string keyword as a value of 2, and so on. And I'll do this for 3 as well. Now, you can leave the comma if you like. We can create a new, an empty thing called a new numbers. And we'll create a list, in fact, just to show you the effect of this. New dict equals a list, empty list. So we have a dictionary here with keys of the names of the numbers, and then an empty list here. We do the same thing, the for keyword. You could reuse number if you like, but we're going to use we're going to now show you a very interesting function which not many people know about actually on some of the forums, and it's called the items keyword. Now this is added recently, and it enables you to get the key and the value at the same time. Now, in order to both effectively show you this, I want to show you a little example actually, so we'll put this on hold. Sorry about this, remember your code, just leave it there. Delete this print statement. Now, if I make a new list, test list equals that, empty brackets, and then add 1, 2. This will mean test list will be a list object with 1 and 2, and you can access the first value by test 0 and second by test 1. Now, a very handy function in Python is actually, if I add this so you can see what it does, and add a hashtag to make some comment, and comments don't get executed, they get ignored by Python, which is useful for showing help or reading later on. This will access each item from the list. But what if we wanted to add each item to the list to the variable? Well, as long as you have the same number of variables as there are items in the list, you can do so. So let's have 1, 2, and the comma means we're defining 2 variables, not just 1, equals test list, or 1, 2 equals 1, 2. And for each one, we'll add a print 1, print 2, and do the same under here by copying and pasting. Now, if we look at our console, we see 1, 2, 1, 2, because it's assigned the first variable to 1, second variable to the second item, which is 2, and so on, both work. with this little snippet of code in mind, here, you can then see that if we do a for statement, for key, comma, value, because we're going to assign two values here, two variables, in dict numbers. However, if you try this on its own, it won't work, because by default it only gives you the key. If you want both, you do dict numbers.items, colon. Then you could do a print key, print value to show you, for example, and that will print this variable key. This will print the variable value to the console, and we press P, and you'll see 3, 2, 1, and then the value 3, 2, 1, as we do. This all works fine. Just to show you by comparison, the other method of doing this would be to copy this, for key in dict numbers, value equals dict underscore numbers key, because you're accessing the value by the key, which is what you do in dictionaries anyway. And if you try this again, you should see it works the same way. So bear this in mind. By the same token, you can access just the keys by doing dict numbers.keys, and that will give you a list, kind of a list, not quite. It'll give you keys data type, which you don't have to worry about because it's basically just a list but you can't assign to it. And also .items, and .items will give you the value. So we might as well put for value in here. Key. I'll better explain this to you. This one does the same as this one. It just does it by the keys list. So those are the same. So get rid of this one because you don't really need to know about it. It's the same thing. But for this one, oh crumbs! I nearly missed out. You have to put values. Sorry, dot values and the parentheses because it's a function. Now this will get the value in the dictionary values. So if you want to find the key, I believe you have to do dict underscore numbers dot index value. And let me just check if this works because I don't actually experiment with this very often. And see if this works. No, don't actually index. I actually don't believe you can. No, you can't search a dictionary by its value. You'll learn this later on, but this essentially gives you the list of values. So if you don't care about the keys, then you can go by the values, or you can use a very complex list comprehension later on, which we're going to look at. So for now, these are the only things you have to worry about: items or just nothing at all. Both do the same thing, except this one's slightly longer, but it's quicker because it doesn't give you both values. So that's dictionaries for you. Let's say we wanted to add them to this new list we made, new dict. Then let's get rid of this bottom one because you know about this already, and put new underscore dict dot append value, and then we print new dict and press P, and we see 3, 2, 1 as we should. And this is essentially dicts and lists. You've looked at for statements as well. This is the for statement, but how about if we wanted to look at comparing two different lists? This is quite an interesting concept. So I'm going to delete my code I've created up here, so if you're worried about it, just save it. And I'm going to create two lists of odd numbers and even numbers. And we'll make a for statement as we've done, but this is a very nice aspect of Python, is you can do more than one thing at once. So let's say we wanted to loop through both lists at the same time. We could therefore get the first value of each list at the same time. To do this, there's something called the zip function. So for item 1, item underscore 2 in zip, which means we're looking to like a zip, a bit like your unzip a file, you get 2 or more items, for example. And then put list numbers and a comma because it's 2 items, as you remember earlier, new numbers. And this will give you 2 variables. Item 1 will be from the first list, item 2 from the second list. We can then check which big number is bigger, and we know that it's always going to be list numbers and new numbers, unfortunately, but this just demonstrates two. And then we'll print that number. So if statements compare. It's like, if this is this, do this, otherwise don't. If item underscore 1 is bigger than item underscore 2, that's the more than comparison. Most of the comparisons work, they're from maths. Print list 1 is bigger. However, we know that's not going to work because list 1 is never bigger than list 2 in all the indexes. So if item 1 is less than item underscore 2, we could do print it works as it should. And this will do it for each item in the list. And we'll see how this works. Press P, it works as it should. That's correct. So our if statements work. This is what an if statement is. An if statement checks. This tells you it's going to check something. This tells you the first item to compare against the second item. You don't always have to have two items, but this is the main way you'll do it. To check if something is the same, you can use an equals operator. This operator says, are you two the same? Because just one equals will set item 1 as item 2. You could have more than equals, which means it's either more or the same as, or less than equals, less the same as. You can also check if it's a float, which type of data it is, but we won't do that just yet. So now we can also tell you what the two numbers added are together to show you that it works. Print item 1 plus item underscore 2. You'll see 3, 7, 11, 15, 19. And 10 plus 9 is 19, and 1 plus 2 is 3, so it works. That is if statements. They're very easy to use, and you'll learn a lot more about them later on. Most of the errors you get is when you've used 1 equals instead of 2. Let's just get rid of this code because I'm going to make some more space. What else do we need to know? Well, so far you are into if statements and for statement. I think the best thing for you is to practice those. Practice creating a few lists, but you could, for example, use strings instead of integers, and vice versa. Now, that's pretty much the end of this first tutorial. The only other data type you need to be aware of is Boolean. Boolean is something you should hear anyway. It's either true or false. Now, Boolean in Python can actually be detected as a 1 or a 0, I believe, because 1 is positive and 0 is negative. Or, sorry, false. 1 is true, 1 is false. But you can also use the true, false keywords. So let's say variable underscore 1 equals false. And you'll see it's blue because it's a data type. 2 equals true. Print variable underscore 1, and if we show the console, we'll see false. So, to show you that you can use numbers as well, if variable underscore 1 equals 0, print false. And you'll see it says false in the console. If we put 1 in there to show it's not just messing up, it doesn't say anything at all. And the same works both ways. There is more to it than this, but this is generally how Python works. So move on to part 2 to improve and learn more.